This is chapter 10, sequences. And so what we're going to do first is what should be familiar. So you got to think back to pre-algebra. You got to think back to the exclamation point and say, oh, what did that represent? Anybody remember? Raise your hand and tell me what operation this represents. Ashton?
Permutation.
Not a permutation, but you're in the right area. This has to be done as part of figuring out a permutation. Anybody remember what this symbol represents? It is a factorial. So, I'm going to write that in red. So this is factorial. F-A-C-T-O-R-I-A-L. Factorial. And if you were going to be technical, you wanted to write it with a variable so you care for any factorial, you would write it n times the quantity n minus 1 times the quantity n minus 2 times the quantity n minus 3, dot, 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 however n minuses, until finally you end up down to 1. So let's write that in the practical way. So do you remember what 7 factorial is written out? Somebody tell me what to write out in writing out 7 factorial. Antonio?
7 times 5 times 4 times 3 times 2 times 1.
Correct. 7 times 6 times 5 times 4 times 3 times 2 times 1. Seven factorial. And if you'll notice, in this situation, the n equals 7, right? The 7 is in the place of the n. Remember, the top part of A there is just to care for any factorial. But to see how it would work with 7 factorial, you don't need to write this, you can if you want. Each n is a 7, right? So the first number is 7. 7 minus 1, that gives you the 6. Here now, 7 minus 2, that gives you the 5. 7 minus 3, that gives you the 4. 7 minus, etc. You keep going until you get all the way down to 1. All right, so go back and find your factorial button on your calculator, because we're going to expand and evaluate. So expand and evaluate. The first one you could do in your head. If they say expand, they want you to write it out like we just did. So they want you to write 3 times 2 times 1. And then evaluate, they want the value. And again, that one you can do in your head. That's a 6. All right, so go ahead and do that with number 2. Expand it, and then find your factorial button on your calculator so you're not punching forever. And punch it out and find the value of 8 factorial. So expand it and then punch it out. Expand it, punch it out. All right, somebody raise your hand and tell me who's got a value here for 8 factorial. John, what do you got?
40,320.
Sounds like you found your button. 40,320. Anybody not able to find their button on their calculator? All right, hold up your calculator, Wyatt, and let everybody see it. Show it to the class. Anybody have anything like Wyatt's? Okay, anybody else need to find it? Everybody else found their factorial button? All right, so the button makes it easy, but what's the button doing? 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Piece of cake. All right. Well, now we have to talk about a factorial sequence. A factorial sequence. Well, actually, the concept of factorial is a sequence in and of itself. So if we have a factorial sequence, and they're going to have to tell you this, A sub n means n factorial. That's all. So it's really what we basically have just done. So we can do the factorial in the opposite direction. And that's what we're doing here in this first example. So a sub n is the same as 1 factorial. And then we're just going to keep going. Windows. The second term is 2 factorial. The third term is 3 factorial. The fourth term is 4 factorial. The fifth term is 5 factorial, etc., 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 etc. Okay? So be careful here because it is a sequence. It is a series. And therefore, the first term is when the n is 1. Just like we have in every other sequence. The second term is when the n is 2. The third term is when the n is 3. Fourth, etc., etc., etc. So again, let me just do this to make things clear. So this is the first term, right? This is the second term, right? This is the third term. This is the fourth. And this is the fifth, etc. Right? That's how you do a sequence. First term, second term, third term, fourth term, fifth term, sixth. It goes on forever, right? It's a what kind of series? Infinite, right? Because of the 3 ellipses, it's an infinite series. So now in the second part, though, we want to write out the value of each term. So 1 factorial is 1. 2 factorial is 2. 3 factorial is 6. And go ahead and do 4 and 5. You could really do 4 and 5 in your head if you understand what's going on. So you can use your button, but I just want you to look up at the screen for a moment. So what's 2 times 1? 2. What's 3 times 2? 6. See, we're always adding that next number. What's 4 times 6? Wasn't 4 factorial 24? Okay, so let me get rid of all this so it's not in my way. So this one is a 24. So the last one should be 5 times 24. And again, you could do that in your head. You got 120, right? And the next one, 6 factorial, will be 6 times 120 for, what is that, 720? And then 7 factorial will be 7 times 720, and now it's getting beyond my head. Maybe your head can handle that. My head doesn't like it. I probably could do it, but I don't like it. That's the idea, because in the sequence realm, you're going one more number higher each time, and it ends up being a multiplier of the previous term. That's a factorial sequence, 1, 2, 6, 24, 120, 720, and then it goes higher from there. All right? That's the idea of a sequence. So here, if they say expand a sub 9, and again, we're telling you this is a factorial sequence, so they want you to start off with 1 factorial, and again, you got to use commas, so go ahead and expand it. And you know what? Let's save time here. Let's go back the other way. Let's just do the values. First term is going to be 1 factorial or 1. Second term, 2 factorial 2. Third term, 3 factorial or class 6. Fourth term is 4 factorial or 24. Fifth is 5 factorial or 120, and finish it out. Okay, those are the first 5. You need the 6th term, 7th term, 8th term, and 9th term. sixth term, seventh term, eighth term, and ninth term. So it was 720, 5,040, 40,320. I got to use a semicolon so I can use a comma there. And then 362,880 gets up there quickly, doesn't it? So again, first 9 terms, right? 1 factorial, 2 factorial, 3 factorial, 4 factorial, 5 factorial, 6 factorial, 7 factorial, 8 factorial, 9 factorial. Is that okay with everybody? Okay. The last thing we want to do is deal with a special situation. If you notice in the formula, we have 1 over the factorial sequence. So 1 over anything is its reciprocal, right? I heard it out there. Come on, Windows, you're being obnoxious. So the sum of the reciprocal of an infinite factorial sequence equals E. What is E? Well, it's commonly called Euler's number, Euler, but I think he's German, so actually if I did it well, it would be like Euler, something like that. But anyhow, it's a value, and it's valuable in math, and it allows us to do some things and calculate some things like population, like bacterial growth. Those are probably the 2 prime examples. And things model the exponential equation with E as the base. That's the situation when you guys get to Algebra 2, we'll do some real life problems with E, and you'll see that in a bigger way. But it's going to be the reciprocal of the factorial sequence. So let me show this to you one other way. Well, let me go a little bit here, and then, well, let me do it this way. Have we done summation in here at all? Have we done that? Okay. So if we haven't, that's fine. Don't worry about it. Just put it looks like an E, but it definitely comes in on the left side, and it's got hooks on the ends of the E. That tells you to sum things up. Notice how we're adding things, right? So anyhow, that's where summation comes into play. The blue box is the formula. The summation is another way to say the same thing. On the bottom, we go n equals 0. That's where you start. On the top, we go infinity. That's where you end. And then we got to say what to do. And what we do is 1 over n factorial. 1 over n factorial. So that's summation notation. We'll get that again later on in our math. But here's what we need to do. So let's take a look at the top one. So it starts at 0. That's unusual. You say, well, I wouldn't have known to do that. Well, that's why we're telling you. So 1 over 0 factorial plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial plus 1 over 4 factorial plus 1 over 5 factorial plus 1 over 6 factorial, etc. forever and ever. Forever. Factorials. Okay, so let's go ahead and find the value. So go ahead and take your calculator, punch in 1 divided by 0 factorial and see what you get. Hit 1, divide by button, 0 factorial. Say it if you got it.
1.
It is a 1. All right, do the next one. 1 divided by 1 factorial. It is a 1 as well. Now do 1 divided by 2 factorial. Adam, you're done already? Okay. All right, I'm just amazed. All right, I hope it's good. 1 divided by 2 factorial. What do you got? Anybody give it in decimal form? 0.5, all right? We're going to go decimals here. It's easier. Do 1 divided by 3 factorial. 0.16 bar. 1 divided by 4 factorial. Give me the first 3 digits. 0.0. So 0.042 when we round off. Do 1 over 5 factorial. Again, just give me the first 3 digits. What? 0.008, and do 1 over 6 factorial. Do 4 digits on this one. 1 over 6 factorial. Everybody got it? So 0.0014, right, if you round off to that 4th digit. So if you were to add these up, you would get the number, the value 2.1828. And I'm going to put a ... because there is a ... But those are the first 4 digits past the decimal point for the value of E. So what is E? It's simply a number. It's like pi. It's an irrational number. It's like pi. It goes on forever and doesn't repeat. And those are called also transcendental numbers. But it's a value. What's pi? Today's Pi Day. It's 3.141 whatever, right? And on it goes. And pi is a relationship of the circumference of a circle to the radius, right? Well, E is the relationship of the reciprocal of a factorial sequence. And believe it or not, the value has value in population, in bacteria growth, etc. And again, we'll get to those later. All right, so that's the lesson 1 through 6. Sorry, it took a little bit longer than I thought. But 1 through 6 due for tomorrow.